Hello everyone, in today's video we will be covering S3.2.1 Organic Compound Representations. Throughout this video we will develop an understanding of formulae and structure. We will cover molecular formulas versus empirical formulas, branch, straight chain, and cyclical structures, and different presentations of compounds. To start off, we will cover molecular versus empirical formulas. In molecular formulas, exact number and types of atoms present in a compound are shown. An example is H2O, which has 2 hydrogen atoms and 1 oxygen atom. In an empirical formula, is the simplest whole number ratio of atoms present in a compound. To show this, we have an example, glucose, with a molecular formula of C6H12O6. There is a ratio of 6:12:6 in the atoms. The simplest ratio of this would be 1:2:1. Therefore, the empirical formula is CH2O. Moving on, we'll discuss carbon compound structures. Firstly, we have a linear straight chain. It is shown by the straight chain in the compound where there are no additional carbon branches that are not in this chain. Secondly, we have the branch chain, where a straight chain can be observed with a branch on the side here. These are typically methyl groups or ethyl groups, with methyl being CH3 and ethyl being C2H5. Lastly, we have cyclic compounds, which are represented by the ring of carbon atoms in the compound. These typically have a prefix of cyclo in compounds such as cyclohexane. Now we will discuss different ways to display a compound. Firstly, we have displayed formula and condensed formula. Both of them show all atoms and bonds and are easy to use. However, they do not show bond angles and atom sizes. We then have skeletal models, which show all bonds and atoms except for C and H. They could be hard to understand, and they do not show atom size or bond angles. In 3D models, all bonds are shown, bond angles are also shown, size of atoms are also shown. However, they are not an accurate representation of spatial configuration. To show these different types of presentations, we have 3 examples. Firstly, hexane. With a molecular formula of C6H14, there is a ratio of 6:14 within the atoms. The simplest whole number ratio would be 3:7. Therefore, we have an empirical formula of C3H7. The displayed formula for this compound is as this. We can see the straight chain in the compound. Moreover, we have the condensed formula, H3C, CH2, 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 CH3. Sometimes this is also shown as CH3, CH2, 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 CH3. Just the start is a bit different, as some people prefer to show this carbon-carbon bond, where sometimes it doesn't really matter for some people. Both of these could be seen in the exam, however. Moving on, we have the skeletal, which is drawn like this. First, you want to get your 6 carbon atoms. Since hexane is a 6 carbon molecule, you have 1, 2, 3, 4, 5, 6, and then you connect the dots. Here we can see the 6 carbon molecules in the atom. It is important to keep in mind that the dots are the carbon atoms, not the lines. The lines are the bonds. Here we have the 3D model of hexane. We can see the 6 carbons, 1, 2, 3, 4, 5, 6, and we can also see the 14 hydrogens, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14. Moving on, we have 2-methylpentane with a molecular formula of C6H15. The simplest ratio to this is 2 to 5. Therefore, we have an empirical formula of C2H5. The displayed formula is shown with our 5-carbon straight chain for the pentane and our single branch methyl group which is shown in the name, 2-methylpentane, on the second carbon molecule. It has a condensed formula of this where we can see 1, 2, 3, 4, 5 carbons in the main chain and a single carbon in the branch chain. Atoms that are in the bracket that are shown in the bracket are the branched molecules. Now we can see our skeletal structure with 1, 2, 3, 4, 5 in the main chain and another one in the branched. We know that this is the branch chain as this is the longest carbon chain that can be seen, and this would not be the short one. Now in the 3D model we can see 1, 2, 3, 4, 5 carbons with this carbon being a branch, and we can see our 15 hydrogens on the 3D model. Lastly, we have cyclohexane with a molecular formula of C6H12. The ratio H6 to 12 could be simplified to 1 to 2. Therefore, we have an empirical formula of CH2. Displayed formula is this, where we can see our cyclic compound structure with a ring of carbons in the compound. That's where the name cyclo comes from. And in the condensed formula, to show the cyclical structure, we can only simplify the CH and not the structure. In the skeletal, we have this hexagon where there's 6 carbons and the hydrogens are not shown. And in the 3D model, we can again see the 6 carbons and the hydrogens that are connected to them. Thank you for watching this video. I hope you learned something from it. Have a great day.